This is the first chapter in Understanding Networking or CCNA. IP history. See, the IP word means Internet Protocol, IP networks, meaning the protocol IP is what we have everywhere in the globe. IP. Using IP, we communicate. IP is the protocol we have in the network to talk each other. Without IP, this online class is also not possible. Internet protocol. Fine. This IP network has got various type of devices like laptops, servers, routers, switches, firewalls. There are a lot of devices, variety of devices. Now they all identified with an address. See, you have a name, I have a name. Everyone has got unique name. Sorry, I cannot say that. Yeah, not everyone has got unique name. There are many people with the same name, but let us take the fingerprint. Everyone has got a unique fingerprint. Likewise, for us to communicate in the internet, every device needs a unique address, unique fingerprint. And that address, we currently use version 4 of that address, and we call that address as IP version 4. For the IP network to identify a device, we need an address. And that address has gone through many versions. The current version that we use is IPv4 version 4 address. See, the protocol is same IP, but the address that the IP protocol uses is version 4. Even we have version 6 now. Now what happened to version 5? Version 5 did not succeed. So only 4 and 6 have become standard. Now what is the difference between these two? IP version 4 is 32-bit size. Very important. Note down, IP version 4 address is built using 32-bit. IP version 6 is built using 128 bits size. You see, IP address is an address that helps to identify a device. Currently, we have two versions of IP address. One is version 4, another one is version 6. IP version 4 is 32-bit size. IP version 6 is 128-bit size. Next. We are going to learn about these to 32-bit, how it looks like, 128-bit, how it is used later. But I just want to give you the history of IP network. This is a part of the history. What is that? In IP, we have an address to identify device. And these addresses are of two versions, version 4 and version 6. Version 4 is only 32-bit size. Version 6 is 128-bit size. The reason for we having version 6 is version 4 addresses are finished. We finished using all the 32-bit address. See, the entire world was using just a 32-bit address to provide identification, a unique identification, which was really a tough thing to manage. But somehow we managed this thus far. And we got a new version so that you no need to manage. You can have enough of address. 128 is really very big address type. 128-bit can provide sufficient amount of IP address that is needed for current and future technology. See, technology is growing every day. Managing with that 32-bit is very difficult. That's why we have version 6. So, in this part 1 of understanding TCP/IP network fundamental, we learned the history of IP. Next, what we are going to learn is the OSI model. OSI stands for Open System Interconnect. Open System Interconnect. What is the meaning of it? When we say system, okay, let me write it down here. Open System Interconnect. Interconnect. See, when we say system, it means any device that interacts over the internet is a system. It may be a laptop, it may be a cell phone, it may be a server, it may be a firewall, it may be a router, it may be a switch. It can be any device that interacts, that communicates over the internet. Now, all the systems are ready. That's what the meaning. Readiness. Are ready to interconnect, are ready to communicate if we follow a model. If the systems that are designed, if they are designed referring to this model, then all the systems can understand each other. Simple. Here, I'm trying to explain what is OSI model. What is OSI model? OSI model is a kind of book, a kind of Bible. Someone needs to refer if he or she designs a system in order to interact with the internet. Even if you are a manufacturer of a computer, your computer should be built according to this model called OSI. Only then your computer and my computer can understand and they can talk. You see, the make of my laptop is Dell. What's your laptop's make? What's your computer's brand? Look at this. See, yours is HP, mine is Dell. But when I send a data, you can understand. When I speak through my Dell laptop, you can understand. When you speak from HP, I can understand. When I send a mail, it goes exactly the same way as I send to you. See, how is this possible? Because both HP and Dell, they have designed the laptop by referring one common book, one common reference book called OSI model. So when a designer designs their system according to this model, the systems can readily interact without any struggle. The systems can communicate and there will be good understanding between the device. There won't be any confusion. When a system sends the data, the other system can easily understand. It is like a common language. See, my mother tongue is different and your mother tongue is different. But we speak English so that we both understand. We both understand each other because of language English, a common language, likewise. My Dell laptop, your HP laptop, they all designed in different factories. But one thing is in common, which is this OSI design. Both the devices are designed as per the OSI model. That makes these two devices to understand each other. See, the entire world systems are designed using one model, one book, which is called Open System Interconnect. Now, this Open System Interconnect has got 7 chapters. Here, they don't call it as chapters. They have got 7 layers. This is layer 1, physical layer. Layer 2, data link layer. Layer 3, network layer. Layer 4, transport layer. Layer 5, session layer. Layer 6, presentation layer. Layer 7, application layer. So layer 1 to layer 7. We got 7 layers. OSI has got 7 layers. What does that layer here means? This OSI describes the 7 steps that need to be carried out whenever a device wants to interact, whenever a device wants to communicate over the internet. See, if we both need to understand what is needed, we both should know English. We should have learned English and we need to speak English. Only then we both can understand. Likewise, when two devices want to communicate, there is need for a preparation. The data that you want to communicate needs to be prepared. And that preparation is of 7 steps. That 7th step is what you call it as 7 layers. It is 7 steps of preparation. Yep. 7 steps of preparation, 7 layers of preparation. Now, this is a standard. OSI is a standard. Who proposed this standard? We all know there is a standardization organization called ISO, right? ISO, everyone knows ISO. ISO certified. You know, when you book a hotel, you look for ISO certified hotel. Why? Because you want a pleasant stay. You don't want some hotel where there is no proper standard. anything you buy, you buy ISO certified. A refrigerator, you want ISO certified. Fan, anything you want to buy, you look for ISO certification. Likewise, ISO has certified this model to be the best model to be followed when a developer develops a system, that needs to interact in the network. You see? So these layers need to be in order. You cannot shuffle it. Physical layer is layer 1, always. Layer 2 is data link layer. You should not mix, you should not shuffle. Always layer 7 is application layer. You should not mix it, you should not rearrange it. This is the order in which you should memorize. Why? Only when you prepare in this order, the packet will be open, means ready to communicate. Everyone can understand only when you prepare in this order. Yeah. So there is a procedure. This is the procedure. For a packet to be an eligible packet in the internet, the 7 layers, this preparation need to be done. Only when a packet is prepared, when a data is prepared in this order, the data can be understood by anyone. See, when I communicate to you, my voice that I'm talking to you is prepared in this order and sent out over the network. And you are able to understand because it is prepared in this order. If the order is rearranged, then the packet will not be a successful packet. Okay, so you should memorize this in order. Physical layer, data link layer, network layer, transport. I'm going to explain you one by one what they do after some time. But first of all, you should know these things in order. The first layer is what? Physical layer. Data link layer is the second layer. Network layer is the third layer. Transport layer is the fourth layer. Session layer is the fifth layer. Presentation layer is the sixth layer. And application layer is the seventh layer. Don't forget this. In the next class, I'll ask this question. I'll ask what is the sixth layer in OSI? And what will be your answer? No. My question is, what is the sixth layer? Sixth layer in OSI.
You talking about the old?
I'm sorry?
No, I was right about
No, I want only the sixth layer in OSI. What is the sixth layer in OSI?
the OSR.
What is the sixth layer in OSI?
Oh, the sixth?
Yeah, sixth layer.
Oh,
exactly. So I'll be asking you a question tomorrow. I may ask you what is the fifth layer? Then the answer should be session layer, fifth. When I say second layer, what will be your answer? What is the second layer? Exactly. Data link layer. Okay, it's actually data link. They missed a word here. It's actually it's actually data link layer. Right, not data. Let me try to correct it. Right? So physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. 7 layers of OSI reference model. Now, you see, 7 layers. Physical layer is down, and application layer is on the top. Actually, when you send the data, it starts from an application. When you send the data from your computer, it starts from application layer of your computer, comes to the presentation layer of a computer, and then comes to the session layer, and then comes to the transfer layer, network layer, data link layer, and physical layer. This is the order. But even though the data originates from application layer, we still call this as layer 7. Always application layer is a layer 7. See, it's a standard. You cannot change the standards. Always application layer is layer 7, even though it appears like a layer 1, even though it looks like, the first layer from where the data is originating. The data originates from application. But still, according to the standard, it's layer 7. All right, it is layer 7. Now let's go one by one. I'm starting with the layer 1 called physical layer. Physical layer. What does it mean, physical layer? What is physical layer in OSI? Physical layer describes about the cable, about the device that we use. And it is a physical layer to which you connect your internet wire. See, on the laptop backside you will have a port. You'll be connecting this type of connector. Or you may have a Wi-Fi. Wi-Fi is another alternative for this type of cable. Anyway, whether it is Wi-Fi or a wire, they are going to send and receive traffic in the form of electrical current. Data is sent and received over the Wi-Fi in the form of radio waves. Radio waves, not electric current. Over the cable, it is sent as electric current, like the telegraph machine. Olden days, we used to have telegraph, right, to send a quick message with a wire. They used to send quick messages. That is what we called as physical layer, using physical cables, physical equipments. We are able to communicate to the remote device by sending our data in an electrical format. See, the electric has got two alphabets, 0 and 1. These are the two alphabet in the electrical language. 0 means what? Off. 1 means what? On. These are the two words the electrical field knows. So using the 0 and 1, we are sending data. The 0 and 1 is called as binary system. Binary. This electrical signal uses binary. We use what? We human beings use a decimal number. The electrical current uses this binary, on and off. On means 1, off means 0. This is how your data and my data is going. Right now I'm talking to you continuously in English, But in the network don't understand my language English, but network understands only electrical current. Yes, right now my voice is coming to you in 0 and 1, zeros and ones to your computer. And your computer now manages to decode into an English language and give it to you in the speaker, and you are able to hear me. See how amazing it is. I speak in English, but it comes in the form of zeros and ones as an electric current in the wire, and you receive from the wire, maybe through wireless radio waves, to your laptop, and your laptop can interpret it, whatever I'm sending in 0 and 1, into my English language. Even the voice, my voice is not getting changed. Even the voice is notified to you in zeros and ones. How amazing this technology has grown now. See? So when we say physical layer, the layer that is responsible for sending your data in electrical current format is what called as physical layer. In another word, I should say physical layer is responsible for the physical connectivity, meaning connecting your laptop to the internet using a Ethernet cable, a wire, or it can be a physical layer like a Wi-Fi access point, a Wi-Fi device which uses radio waves. Yeah. So physical layer is layer 1. Physical layer is responsible for physical connectivity. Physical layer means the layer which describes the cable type, the equipment type, which will carry our data in the form of electric current that can support our communication. Now, when we talk about devices, there is a device called hub. Hub is considered to be a physical layer device. I'll talk about this hub later in detail, but this hub we don't use because there are a lot of drawback in using hub. Hub is a device. It's a device. Let me show you in the internet. This is an example for wired hub. This is like a wireless hub. So we don't use hub anymore. See, these are all a little bit advanced hub. They are switches actually. They are switches. But when I search as hub, okay, this is hub. This one. But we don't recommend using hub, right? Like this. We don't use hubs nowadays. But what I'm saying is, hub is a layer 1 device. We'll talk about hub in detail a bit later. See, this is an example for hub. But I'm seeing, big prices for hub, but not recommended to use. Okay. Hub is also a network layer device. It works in the physical layer. It works in physical layer, but don't use it. Why? We'll discuss later why we should not use hub. Now, physical layer is there on every device, every computer, every router, every laptop. Your laptop has got a physical layer. If you see behind your laptop, let me show you again another picture. If you see behind your laptop this type of port here, this one or this one, this is the port which we consider as a physical layer port. You see, even here in this is where we connect our Ethernet wire. It's a physical layer. It's a physical layer through which we communicate. This one, it's a network port. We call it as NIC, NIC, Network Interface Card, NIC port, NIC port. It's a physical layer. right? This is the port to which you'll be connecting this cable. This will go inside this. All right. So we have just learned about the very first layer called physical layer. Out of 7 layers, we have covered the physical layer. What is physical layer? Physical layer is the one which explains, which describes how the physical connecting cable or equipment need to be. It describes how the equipment should be. The equipment should carry our data in the form of current. When we say current, it is on and off, 0 and 1. Using that 0 and 1, our data is going to be sent. So that when you receive those zeros and ones, you will exactly learn what I sent. When you receive the voice packet, see from my laptop, I'm sending the voice and the screen sharing video. You are able to see what I am showing and you can hear me what I am speaking. This is all amazing because, the physical layer is working so fine. It can take our data and put it in the form of zeros and ones in the electrical signal so that when you receive as an electrical signal, it can revert back to voice and video with that 0 and 1. So that's the job of the physical layer. So physical layer is not only a physical connection with the Ethernet port, physical layer also means the access, wireless access point. The Wi-Fi in your home, you may be connecting your laptop using Wi-Fi, same like mine. And the Wi-Fi uses radio waves. Radio waves. Now that is what physical layer is. Anything that brings in and takes out the data from and into your computer is a physical layer. Do you have any question on this first layer? Please ask. Wonderful. Now next comes the data link layer. Okay, here is an example for physical layer. I told you, physical layer, there is a device called hub works in physical layer, and I also said don't use it. I showed you some pictures. See, here is another picture. This is a hub. And we can connect all the devices. See, you with the help of hub, you can communicate between this A, B, C, and D computer. If you don't have hub, you cannot communicate to more than one device. See, if I have one laptop, another laptop, if I connect the cable back to back, only these two can communicate. Alpha and beta can communicate. But if I have another computer, theta, I cannot. It's omega, no? Omega. So omega cannot communicate to alpha and beta because we don't know where to connect this port. I have a wire, but I don't know where to connect because the port is engaged here. There's one NIC card here, there's one NIC card here, they're fully engaged. But if you have a media like this with many ports, through this you can communicate to B as well as C as well as D. All these four can communicate. But there's a big disadvantage in using hub. That's why there I wrote don't use. I'll tell you what is the disadvantage later. We'll talk about the devices and their use case and their differences and their drawbacks later. I want to keep it as a separate topic. I don't want to mix with the OSI layers that we are learning. Right now we are learning the OSI layer, which describes the standard for communication over the network. in which we have learned the first layer called physical layer. Now we are getting into another layer called data link layer. The data link layer, data link actually, the data link layer is the second layer, and this is the layer where the switch, say switches, not hub. In the previous case, it was hub used as the layer 1 device. As a layer 2 device, we use switches for communication. Now, yeah, it looks same, but internally, inside the box, they are not the same. The working principle, the design, architecture is different. You see, uh, you have a very basic car, and you have very high-end BMW car. Both are car for transportation. You can use for going from one place to another. But definitely, both the cars are not same. One car is a very low-end model, very cheaper in price. For a long distance, you will not feel comfortable, and it will not go fast. And the other car is very costly, very smooth when you drive. And when you drive long distance, you don't feel tired. But outwardly, both looks car. Both looks like a transport device. But you don't use the first one to go long distance. It's not comfortable. You don't have that shock absorbers. You don't have that luxury because it's a low-end model of the car. You know, very old, let's say Ford car. Very old Ford car, and then a very brand new, latest model BMW. Big difference, right? But outside, when you say, man, both are cars. Likewise, hub and a switch looks similar when you see, but switch is very fast and very clever device. We use switch. We don't use hub because hub is a dumb box, dumb device. Let me show you. Both hub and switch appears to be similar, like a rectangle box. But they are not same internally, they are different. They're different. Switch is very costly compared to hub, and hub is having less number of port. You see, maximum number of port in a hub will not exceed more than 8. But if you take a switch, even you have 300 port switch, 300 port switch. Switches are very clever and fast communicating device, very intelligent device. Hub is a dumb box. As of now, I just want to stop here talking about the hub and switch. We'll talk about that in detail later when we go to the devices class. Right? So the switches are considered to be a layer 2 device. You know why? Layer 2 is the place where the MAC addresses are considered. See, what is a MAC address? MAC address is an address which is unique to your computer, unique to the port of the device. The MAC address on your laptop will be unique throughout the world. No one will have your MAC address. Your MAC address is only for you. No one on earth will have the same MAC address as your laptop has got. You see, so the MAC address of the device is also used to identify to where the packet should go. Like IP address, MAC address is also important for communication. And that MAC address is handled by this layer. For communication, our data needs MAC address, from which MAC address to which MAC address the packet should go. That is being decided by this layer 2, data link layer. So the switches, because they use MAC address, they got the MAC table in it. As a result, they can do communication very fast using the MAC address, whereas the hub don't have this MAC table. Hub don't understand the MAC address. They don't understand anything about layer 2. So hub is not an intelligent device. It always broadcasts because you don't know who is connected where. But the switches, they learn MAC address. MAC addresses, as I said, it's a unique identification given for every device. So your switch knows where your computer is connected and where my computer is connected. So when we communicate, it will easily connect us both. Whereas hub never learns anyone's MAC address. When I communicate, it will go to all who are connected to the hub, which is bad. That's why we said in the previous page, don't use hub, don't use. Switch is an intelligent device. It learns the MAC addresses of the device that are connected to the ports. So if I connect one computer here, another computer here, the MAC address of all these computers are learned in this MAC table. So that when a computer wants to talk to another computer, the packet goes directly to that computer, not to all other computers. Now, in layer 2, our data has got a new name called frames. The data, when you give MAC address to your data, MAC address from where it is going, to where it is going, from where it is coming, our data will be called as frames. Our data will be called as frames. Right? See, we have seen two layers so far. One is the physical layer, the other one is the data link layer. And we have seen that in order to communicate over the internet, there is a need for preparation. Your data need to be prepared by every device that wants to communicate. And that preparation has got 7 steps. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Only when this order of preparation is followed, our data will be an eligible data over the internet for communication. Only then the devices can understand each other. All right. So this is what our today's class was. We learned the small history of IP address. We have currently IPv4 address, which is 32-bit, IPv6 address, which is 128-bit, and we got the 7 layers for successful communication. Out of the 7 layers, we have seen 2 layers today. Any question on what you learned today? Wonderful. So